it's not through our major. And some of them just, they have a lot of life experience. And if this is going to mostly run for freshmen and sophomores, running a pilot for freshmen and sophomores will help you set up.
Be helpful. Yeah.
And then the seniors, if they're in chemistry and they want to take this as a senior, well,
All right, everybody. Sorry about that. Started a little late today. I was on another call, so this may actually interest some of you that are showing up today. So, as always, I'll remind you that this is an interactive session. I'm happy to take questions, post them on the YouTube chat, or over on the forum. I'll be peeking at both places periodically. Just an announcement, since this is what I was just talking about with some colleagues. For some of you that are not majoring in CS or are not CS plus majors, we're actually planning on offering a new course targeted at you. This is a course that will eventually become part of the CS program, but we're running as a prototype next semester. This is a course that will teach C++. It's designed as a follow-on to CS 125, and it will help prepare you to take CS 225, some of you that are headed that direction, maybe to complete a minor, maybe because you want to transfer into computer science. So anyway, so that course is going to come out. We have a fantastic new faculty member, Michael Nowak, who we hired, has a lot of experience in C++. He's going to be teaching it, and I'm super excited. I helped design this class. I'm super excited about it. So I will have more to say about that. I'll post some announcements on the forum later in the class once that's on the books. I don't know exactly what it's going to be called next semester because we're kind of, again, this is a prototype class that will eventually start to offer officially and actually be required for all people continuing out of 125, both majors and non-majors. But next semester it's a prototype, but it may still interest some of you because it'll help keep you programming, give you some experience in C++, and make it more likely that you're going to do a fantastic work in CS 225. All right, so anyway, announcement just to segue from my previous call. So today's lesson is on loops. This is our last kind of lesson on core computer capabilities. So we've looked at how to store and manipulate data using variables. We've looked at how to make decisions in our computer programs using conditional expressions and conditional statements. And now what we're doing is we're talking about how to get the computer program to repeat something multiple times. And what we'll see throughout the rest of the week and throughout really the rest of the semester and throughout your rest of your career in computer science is that really pretty much everything you do with a computer boils down to some combination of these capabilities. There's one other additional capability, which is to communicate. So two computers connected by a wire, that big complicated wire that we call the internet can send data back and forth. We'll talk more about that a little bit later in the class. But on some level, what your computer is doing locally, right, in the computer itself, is a combination of these basic capabilities. So manipulating data, making decisions, execute this chunk of code, don't execute this chunk of code, and repeating things. Repeat this chunk of code over and over again. So today we introduce you to, and I'm not going to claim that this is the most exciting lesson that we'll do all semester. It's really just sort of still building up our foundation, but this is really kind of important. A question about the class in a minute. Maybe we can talk a little bit more about that towards the end of the hour. So this lesson introduces you to two loops. So the idea with a loop is that I'm going to indicate that a particular part of my program should be repeated. And what I want is, so to do that, we sort of think about what's required, right? What do I need to be able to tell the computer? So the first thing I need to be able to tell the computer is what part of the code to repeat. The second thing I need to be able to tell the computer is when should that code be repeated, right? So I'm going to have a chunk of code, and this is similar to our if statements, where I'm going to use a block, right? So here's our first example of a loop. You'll see that the loop declaration has both of those things that I just said that were required. So the first one is, how do I tell the computer which code to repeat? And to do that, just like with my if statement, remember with my if statement, I need to tell the computer, execute this code if this condition is true. Now, I'm going to tell the computer to continue to execute a chunk of code while this condition is true. So we've moved from our if statements to a while loop. On some level, this is also a while statement, but we typically refer to it as a while loop to make sure that we remember exactly what function this is playing in our program. So the while loop has three parts. It has the keyword while, which is how we start off this particular statement. just like an if statement, enclosed in parentheses, I have a conditional expression. It has to be something that evaluates to a Boolean. And this could be a single conditional expression. It could be a compound conditional expression, whatever. But this has to be something. This could be a variable. I could say Boolean. No, it's not Boolean loop is equal to true, and then I could have loop inside here. So it has to be something that Java can evaluate to a Boolean value, either a Boolean variable or some type of conditional expression. And the way this works is that when Java reaches this point in the program, it's going to start executing this loop and continue executing it as long as this condition remains true. So when Java gets to a while loop, it checks the condition and then it enters the body of the loop. So that's the third part of the loop declaration over here. Remember, I have to tell Java what part of the code should be repeated. So this indicates how long I should continue to run the code. Bless me. And over here, I have code that indicates the part of the program that should be repeated. So all the code inside this block is the code that's actually going to be repeated multiple times. So, when the computer executes this, line 1, declare initialize a variable named I, set it to 0. Line 2, I get to my while statement. I've got a conditional expression in here. I check the conditional expression. So is the current value of I less than 8? I is 0. 0 is less than 8. I enter the block. When I get to the bottom, unlike an if statement, so if this was an if statement, I would just keep going. But with a while loop, I go back to the top. I check the condition again. So the body of my loop in this case is incrementing I. That's what this line does. So first time I enter the loop, I is 0. The second time I get to the top of the loop, I is 1. I check the condition again. It is, I re-enter the body of the loop. And I will continue to enter the body of the loop as long as this condition remains true. Now, when you have a while loop, usually you want the while loop to stop at some point. And so normally there's something happening inside the body of the loop that's going to cause this condition to eventually become false. So if I start off executing the loop, I probably want to stop. There are some times when you can write what's called a while true loop or an infinite loop, and there's places where that's appropriate, but they're few and far between. So in this case, what I'm checking in my conditional expression is whether I is less than 8. And what I'm doing inside the loop to make sure that eventually I is not less than 8 is that I'm incrementing I. So regardless of the value of I, even if I started I at like a really small value, like -1024, you'll see that this program is eventually going to complete because the first time I go through the loop, I will be -1024, the second time -1023, the third time -1022. So it's getting closer to making this condition false, one step at a time. Actually, with this loop, no matter what I set I to, this program will complete. Not if there's a check style there. So imagine I is 1024. So now I give it a big positive value. What happens this time? The first time Java reaches the loop, it checks to see if the condition is true. In this case, the condition is not true. And so it never enters the loop at all and just keeps going. So it's possible to have a loop that's never executed. There's no requirement that a loop be entered at all. If I reach the loop and the loop condition is already false, then I don't execute the loop. And there's times where this happens. Okay, so let me go check the questions. Any questions on this material? Like I said, shout out in the question thread if you guys have any questions. All right, so our second loop, and these are the loops, right? Like this is it. These are the loops that we're going to use throughout the rest of the class when we need to repeat something. It's not like there's a whole bunch of these saved away. There is one more loop in Java that you can use. It's not super important. I'm not sure I'll present it at all, and if I do, it'll be sort of in a grab bag maybe later in the week. There's a variant of a while loop that we use in certain situations. But these are the most common loops. And this loop, what's called a for loop, is by few. Maybe one day when I have some free time. So in May, I'll sit down and I'll write a program to scan through a bunch of Java source code and kind of count how many times different loops appear. Based on my own personal experience reading and writing code, I would argue maybe 80%, if not 90% of the loops that you find in Java source code are for loops. The rest are a mixture of while loops and then that third loop variant that I didn't present in this lesson, right? That's quite uncommon, but handy sometimes. So here's the idea behind a for loop. The for loop probably represents the most complicated Java syntax that we've seen so far in this course. And so I kind of want to slow down and make sure that you understand how it works, and then also kind of where it comes from, right? Why does this strange thing exist? So when we start talking about loops and arrays, so yesterday we saw arrays, today we're seeing loops. And that data structure we looked at yesterday and this programming construct, this language feature we're talking about today, are really totally made for each other. And one of the things we'll start doing tomorrow, Thursday, Friday, is we'll start using loops, arrays, and decision-making and the ability to store and mutate data and work with data to actually start to build some simple problem-solving strategies using code, what we call algorithms. But loops and arrays are very, very intertwined when it comes to programming, because frequently what we're doing in a loop is we're using that loop to go through an array and do some computation on it, right? So for example, let's say I had an array that stored all the sequences in the human genome. I might have a loop that goes through that array, one base pair at a time, and is looking for a particular pattern, right? This is how you might look for a particular mutation that might give rise to a particular disease or something like this, right? Alternatively, if my array contains a bunch of audio samples, my loop might be going through that array and increasing the volume, right? So I might be taking every sample and making the amplitude bigger to produce a louder signal, right? Or a signal that would play louder on your speakers, right? Or I might be doing some more complicated audio processing to make the sound different, right? So when we use loops with arrays, we frequently want to do something like this. So we have a while. This is a very common while loop. Sometimes we refer to the variable that we use here and inside the loop as the loop index or the loop variable or an index variable. And here I'm declaring the index variable on line 1 on its own line. I have a while loop where the condition is that the index variable is less than some bound, and that bound could be a literal. Sometimes that bound is a variable, the value of a variable, whatever. And then, sorry, this is actually wrong. I'm going to go fix this when this is over. At the bottom, I increment. So at the bottom of the loop, I increment the loop variable. Okay, so 3 parts to this. I have a loop variable. I is an okay name for loop variables. It's sort of conventional. I have a conditional expression that's checking whether that variable is less than some limit, and then I increment that by 1. And so you think of this really, there's, other than the work that I'm doing inside the while loop, which is specific to the problem that I'm trying to solve, there's really 3 parts of this. The loop variable, which here I declare on line 1, the condition that's being checked, and the update that I'm doing to the loop variable every time I go through the loop. And so a for loop is designed to simplify that pattern. Now, for loops aren't required. You can do all the programming you need to do this semester using a while loop, but people would find you a little weird if you did that. If you went out and looked for a job in industry and you're like, I never write for loops, they're probably gonna be like, okay, well, next candidate. Because this is just a convenient way of combining all these 3 things together. So you see the keyword for, you see a block of code over here at the end. So this is very similar to a while loop. I have a keyword that starts off the statement, and then I have a block of code that's going to be repeated. Inside these parentheses, unlike a while loop where I just had a simple expression, a for loop actually has 3 parts. It has something that evaluates to a conditional expression, that's still in there, but it has 2 other parts. The 3 parts are separated by semicolons, so you can see one here and one here. The first part is this statement is only executed when the loop when I reach the loop. Okay, so this is only executed once. Here what I've done is I've used that to declare my loop index variable. But actually, to be honest, you can put anything you want in here. I'm just showing you what the most common way to use a for loop. The next part of the for loop, so I have a statement that's only executed once when I reach the loop. In this case, I'm using that to declare a index variable I'm going to use in my loop. Then I have something that has to evaluate to a Boolean value, so a conditional expression that is checked every time before I enter the loop. As soon as this evaluates to false, I stop executing the loop, jump to the bottom, and keep going. So this is identical to the condition that's used in the while loop. What I'm doing here is I'm trying to kind of line these up for you so that you see where the different parts of a for loop came from. The final part is this increment, and that's the update that's applied at the bottom of the loop. You can think of that as being snuck in here right before, but to be honest, actually that's a little inaccurate. This is actually executed every time I reach the top of the loop again. Okay? Here in my while loop, I do that at the bottom, right? But the right way to think about it is, it's not executed the first time. This part of the for loop declaration is evaluated the first time. This is evaluated every other time. So every time I get back, I return to the top of the loop. And so if I put my print statement in here and run this, you'll see that these two loops do the exactly same thing. This loop is more compact, and that's the reason that this exists. Essentially, just as an aside about how sort of programming languages evolve and change over time. When programmers, you'll find this out as you read the Coder's book, right, by Clive Thompson. Programmers, one of the things that will happen to you once you learn the power of computer science and programming is that you will become excited about using that power. Sometimes people refer to this as laziness. It's not really laziness. You just want to, you're like, hey, I have this set of superpowers now. I want to use them to solve problems. And the author in that book actually relates some stories and then has some stories that he tells that related from other people. But he has some of his own examples of how once he started to learn how to program, he found all of these uses for that skill to make his own life a little bit simpler, to help him out with these kind of boring, mundane tasks that he didn't like, right? So as a computer scientist, and again, as someone who knows how to program and knows how to harness the power of computers, I'll just warn you that when you find yourself doing something really tedious, you will think, how could I automate this, right? How could I write a computer program to do this instead of having to do it myself? This is one of these sort of like hazards of the profession. This same impulse gets applied to programming languages, right? So if you think, computer scientists are lazy, right? Efficient, eager to use their superpowers when it comes to, solving problems in the world. When it comes to actually writing computer code, they're even, when they see a pattern, they want to exploit that pattern. So, and I don't know what the actual story is here, but, it's possible that some earlier programming languages only had this one type of loop, right? A while loop, because this is really all you need. But some programmer realized, hey, I've been writing these same three statements over and over again, declare and initialize my loop variable, while statement that's checking the loop variable against some condition, and then some update to the loop variable that happens every time I go through the loop. Why can't I just put that all in one place to simplify the loop so that the declaration is a little bit easier to understand? And so, out of that desire came this for loop, which now became, the most commonly used loop that you'll find. Okay, so below here, and I'm not going to dwell on this, one of the things that I actively try to avoid in this class is teaching you sort of the goal of 125 is to give you an understanding of the basics and a solid foundation on which to build. As part of that, we don't always introduce every single situation or every single scenario that you might encounter as you learn how to program, and we're not so for example, we talked about conditional expressions. There's all these complex rules for how conditional expressions are evaluated and what part gets done first and second. And I don't, I'm not going to teach those to you and expect you to remember them because you don't need them when you're just getting started, okay? Someday, if you find yourself having to write a really complex conditional expression, you need some help, feel free to, shoot me an email or something like that. Be like, you should have taught me this in 125 and I don't know how to do it. I'll be like, okay, well, here's the website to go to that explains all the rules, and then you just have to kind of apply them. Same thing with for loops. So you can write all sorts of different types of for loops, including initializing the variable differently, different types of checks, and different ways of updating the variable. So for example, I could do you could do this as well. You could put all sorts of more complex statements inside here. I don't care. Probably the only place you would ever write a loop like this is on a test in an intro CS class. And don't worry, you won't have to do that because these are just, not to say that there's no loop like this out there in the world, but it's these are weird. But you can start off the loop variable at different places. You can check lots of different boundaries. This is pretty common. And you can modify that loop variable in a variety of different ways. So instead of adding 1, I could add 10. I have loops that go down, right? So instead of having the index variable start at 0 and go upward, I can have it start at some value and go downward until it reaches another value. And these are totally fine, right? So this will do something, maybe that's useful. I like 8, so this is like a bunch of numbers that end with 8, so I'm happy about that. I like powers of 2, so this is a bunch of powers of, well, actually not all powers of 2, most of them, not 12, but anyway, so these are examples of other ways to use these loops, but like I said, these are not particularly common. You do sometimes need to write a backwards loop, right? So a loop that, and this will make more sense when we talk about arrays, but instead of going through an array forwards from the beginning to the end, goes through the array backwards from the end to the beginning. We'll do some examples of that later in the week. So having a loop where the index variable starts at a positive value and moves down to 0 is not unheard of. But this type of stuff, have I ever written a loop like this? Maybe, not often. It's just not something that you're going to need to master. Other little bit of arcana about loops, the 3 parts of the for loop, the part that gets executed once when I reach the loop, the check that gets executed every time before I enter the loop, and this update that only gets executed when I return to the top of the loop, all optional, okay? So in this case, what's going to happen, right? Well, you'll see here that I see the same loop I saw before, except I've moved the I++ out of the for loop declaration and into the bottom of the loop. So that's doable. I can omit the variable declaration entirely. So in this case, now I have something that looks a lot more like that while loop, right? It's a for loop, but, it's angry about this. Okay, so I guess I'm going to put some white space around there. It's angry about that. Okay. After fighting with check style, I get this to work. So in this case, this almost looks like my while loop. In fact, if I replace this with while, it does the exactly same thing. So, again, kind of do this because you can do it, right? And then this loop, which emits all 3 parts and just has 2 semicolons in the loop. And this loop is going to, I don't know, when I was a kid, I had some exposure to computers when I was growing up. I remember in my middle school, I think we had a little part of the room where they had some Apple II computers set up. And you're a kid, and so you were trying to mess around, and typically these computers would have BASIC installed, and so you could write a BASIC program that was like this. This is a different computer language, to just print something over and over again to the screen, and sometimes the teachers wouldn't know how to turn it off, right? And so that would be kind of funny. And actually, there were some really nasty variants of that program that actually could not be shut down at all. You actually had to power the computer off. So anyway, if you just want to print sweet over and over again because you're pretty psyched about something, this is the loop for you. This loop will never stop, and you'll see what happens down here is that eventually our playground program that's running your code realizes like this piece of code is probably never going to end, you'll see that it actually did it produced quite a bit of sweetness before it was stopped. It produced about like 173,000 lines of sweetness. Computers are really fast. The other thing I'll point out is that this is not usually the way to write what's called a while true loop. If you want a loop that never terminates, this is a better option. This does the exactly same thing, but you know, when you're a programmer and you see this, right, this statement in a program, this is like one of those like red flags that's waving in front of you, right? It's like danger, right? Something is happening here, and I've got to be very careful with this type of loop. Now, there are times when a while true loop is the right thing to do. I can't explain why yet, but over the next few lessons, I'll show you ways to stop a loop from inside. So there's actually a way inside the loop to break out of it and cause it to stop executing. So in those cases, sometimes using a while true loop is appropriate. But again, whenever I see this, if I'm reading code or if I'm writing my own code, you know, if I write a while true loop, I usually sit there and just take a deep breath and think like, okay, you know, okay, Geoff, can you guarantee that this is not going to try and just run and run and run forever, if that's not what it's supposed to do? All right, but like I said, after sort of quickly reviewing these different loop variants, this is the loop, okay? This loop. If there's one loop that's going to roll off your fingers after a couple of decades of doing this, this is the loop. Start I at 0, run it up to some limit. Sometimes that limit is a literal, sometimes it's the value of a variable, but you know, run it up, increment it by 1 every time, do some work inside the loop. This is the loop. This is the workhorse loop. This is the one that you will write by far the most often. All right, one little bit of last thing to just work through today before I just sort of go into full-on Q&A mode. Loop variable scope. So when I said before that there was no difference between these two loops, this while loop and this for loop, I wasn't being entirely accurate. And let me show you what the difference is. So let's say that I want to know what the value of the loop variable was when the loop stops executing. So in this case, I can print the value of I after the loop finishes. Why can I do that? Well, I declared I outside the loop. Remember our rules about scope and where I can access variables that I've declared. So when I declare a variable, when I'm indenting my blocks, I'm able to access that variable either at the same level of the program or to the right. So I can increment I inside the loop because this block is contained in the same inside the block where I declared I. And I can also access I down here after the loop completes because this statement is at the same level in the program as the place where I declared the variable. Now again, this is just a shortcut that you can use, and you can only use this if you indent things properly. Now let's try the same thing here. So I'll try printing the value of I, and now I've got a problem. And the reason for this, and this is an important difference between this syntax for doing a loop and my for loop syntax. When you declare a variable inside the for loop, inside in this slot in the for loop statement, it's only available inside the loop. So this variable that I've declared and initialized here, I, is only available in the block that's being repeated. So inside that block, I can print it, and that will work fine. Outside the block, I can't print it because it's no longer in scope. So it's almost as if it was declared inside the loop. Now, what about something like this? Can I do this? Okay, well, so now this is also different because now I'm declaring another variable named I, but I already have a variable named I that's still in scope. And so this isn't going to work, right? In the sense that when my for loop declares a variable named I can't redeclare a variable named I with the same name inside the loop. Now I can declare another variable called J. Now it's still mad about this. But you'll see J is redeclared and initialized every time I execute the loop. We'll talk about this more later in the week when we do some examples. So I can put whatever code I want in here, but remember that code is run every time the loop body is executed. So it's essentially like you get to this loop, you start executing it. When you enter the loop, you tell Java, hey, I want to use a variable named J inside the loop, and the initial value is 0. And Java's like, sure. And so I use it, I print off its initial value, and then I get back to the top of the loop, and I'm like, hey, I want to use variable named J, and its initial value is 0. And Java's like, sure. Because it forgot all about the other variable named J, because every time I rerun the block, I can redeclare new variables. And when I get to the bottom, Java will forget all about it. And that's important to understand because if I do things like this, you'll see that I don't get the old value of J. J is being reinitialized every time I come through this loop. All right, let me go check the chat, see if I've got any questions. Yes, does I++ mean, yep, exactly, right? If you wanted even numbers, you could do I plus equal to 2. Yeah, exactly. So we've got great answers in the chat already. Those are yeah. So exactly. If you wanted to go up by 2, let's do that. Let's just print even numbers, right? So now let's run this up to something, I don't know, 32 maybe. And if we did I plus equal to 2, and then I rather than J, there we go, right? So now I've got all the even numbers starting at 0 up to 32. Because 32, so what happens when I get to the value 32? So when I is 30, I go back to the top of the loop, I add 2, I is now 32. 32 is not less than 32. And so I stop entering the loop and I continue on. And just for fun, why don't we print out all the odd numbers right after that, right? So now I'm starting I at 1, right? I'm running up to the same limit, and I'm putting off all the odd numbers because I'm adding by 2 every time. And so I can put a loop inside a loop. I can put a loop after a loop. I can put a loop inside a loop, right? Let's declare a new loop variable. I need to use a different loop variable because I is still in scope here. So let's run J up to 16, and let's we'll print J. We're just having fun. This is fun, right? So now you'll see, okay, 10, first time I loop is 10, 0, and 8, 12, 0, and 8. I'm going to see the same values for J every time. Why don't we do this just to make this more fun? Now, the first time I come in here, I start at 0, so I see 8, and then, well, I guess this is only ever going to print 8. Let's run this up a little bit higher. Oh, wow, okay. Oh, okay, no, I made a mistake. This is not good. I can't add I to that. Not even sure what's. Yeah, okay, so, oh, I see. So you guys might wonder, like, what's wrong with this program? My program never stopped. So actually, since we wrote this together by accident, let's just talk about what's happening. So I entered the first loop. So the first time I go through the first loop, the value of I is 0. I print 0. Then I start the value of J at I. So my initial value for J is I. This loop will continue as long as J is less than 32. But here's the problem. Every time I go through the loop, I'm adding I to J, but I is 0. So J starts at 0 and never gets any bigger. So this is why the first time I go to what's known as an infinite loop, and then eventually terminate, stopped. So what I was trying to do here is actually have J equal 1. If I do that, what you'll see is that this will work, right? And the uses for these nested loops won't make a lot of sense for us until we start talking about multi-dimensional arrays. So we'll get there in like a week or so. We'll be talking about working with. So now we're working with linear data and arrays. We'll talk about working with 2-dimensional or 3-dimensional data by using what are called multi-dimensional arrays. And that'll allow us to work with even more types of data that we find in the world, particularly things like photos, right? So a photo is a 2-dimensional array of pixels where every value in it corresponds to a color. And if I make those pixels, the individual values, small enough, I can fool you into thinking you're looking at a continuous image rather than a series of squares, right? All right, great question. Got me to write an infinite loop which is always fun. All right, let me check I think we're, all right, I don't see any questions here. So I will, since I brought it up, I'll briefly mention so I'm almost finished. I'm briefly just going to touch on, somebody asked about 120, the new C++ course. This is a course that is going to be designed differently than 126. I don't think the courses are really directly comparable to each other. 126 was designed in certain ways that made it very difficult for us to teach the course to large numbers of students. And so in order to accommodate a larger number of students, because we really want everybody to get that preparation that you need to succeed in 225, we're making some changes to the new C++ course to accommodate that. So I could certainly talk maybe during, I'll set up office hours soon, or one of our more individual sessions about exactly what those look like. But it's certainly not just a larger version of 126. This course has a different set of objectives. That's a great question. Those of you that are CS majors aren't going to be affected by these changes. If you were entering next year, fall 2021, you would be affected by them. But because you entered this year, none of this change is going to affect you at all. You'll take 126 next semester, and then you'll take 225 next fall, and you'll go on your way. All right. Thanks, everybody, for showing up today. I'm going to log off if there aren't any additional questions, but it's good to see everybody, and take care of yourselves, take care of the people around you. It's tough times out there, sort of a dark world that we're living in, but hopefully, these we have a chance to be together. You guys have a chance to interact with the core staff. Oh yeah, I'll do my usual plug for today's upcoming sessions. So as always, we have our labs going on today. So if you want a little bit of extra help, you can drop in on those. We have concept review. This quiz review tomorrow is not happening because we didn't have a quiz. I'm going to delete that. We have our concept review with Blair starting right following me. Then Shruti and I think who is with her? And Garvita will go through today's lesson again at 1 o'clock. I expect people will be there because you guys were with me. And then 2 homework sessions today on today's homework problem. So for those of you that might have joined up a little bit late, keep in mind that we're coming up to the deadline for that first set of homework problems. So starting next week, starting next Tuesday, we'll take Labor Day off, but starting next Tuesday, we will have a homework problem, and it'll be due every day. So it'll be due to the day that it's assigned. I hope that those of you that are in the class are getting used to that schedule, but we still have some people that are signing up late, and we're helping them get bootstrapped. And so if you're in that boat, or if you're just a little bit behind, you have until the end of the week to catch up and finish up all of the initial homework problems, which are all due on the 6th, which is Sunday night at midnight. Then we'll take Monday off, celebrate Labor Day, and starting on Tuesday, we'll be in the rhythm of doing 1 homework problem per day, due at midnight. So just keep that in mind. That's coming soon, and get used to getting into that rhythm.